discuss the solutions of transmission line equations. So from the previous video, we have seen that the transmission line is given by dou square V by dou Z square is equivalent to gamma square into V. So the one possible solution for a differential equation of this type is given by V is equal to V plus into e raised to minus gamma Z plus V minus into e raised to gamma Z. Now gamma is known as the propagation constant and gamma is given as alpha plus j beta. Now this can be split and written as V plus e raised to minus alpha z into e raised to minus j beta z plus V minus into e raised to alpha z into e raised to j beta z. Now here these factors V plus and V minus are complex quantities. V plus and V minus are complex quantities. So V plus represents the wave that will be traveling in the positive z direction. This is traveling in the positive z direction, and V minus is the wave which is traveling in the negative z direction. And beta z is known as the electrical wavelength, electrical length of the line and is measured in radians. Similarly, if you consider the second equation, that is given as dou square I by dou Z square is equivalent to gamma square I. So the possible solution will be I is equivalent to y naught into V plus e raised to minus gamma z minus V minus into e raised to gamma z, which can also be written as y naught into V plus e raised to minus alpha z, as gamma is given as alpha plus j beta, into e raised to minus j beta z minus of V minus e raised to alpha z into e raised to j beta z. So these will be the equations, and similarly the characteristic impedance, which we write it as Z naught, can be written as 1 by y naught. So y naught is the reciprocal of characteristic impedance, admittance. So this is given by the equation root of z by y is equivalent to z is given as r plus j omega L by g plus j omega C. So if you consider the characteristic impedance, Z will be considering in the transmission line all the series components, which is R and L, and here we will be considering the parallel components, which is G and C. And the voltage wave can be represented as this will be e raised to minus alpha z, and this will be e raised to plus alpha z, and this will be v plus, and this will be v minus. So this is the voltage wave where we have positive and negative directions. And similarly, the current wave can be represented as current wave. Also will have both positive and negative direction, and we can also represent this as I plus and I minus. So this is an important formula, that is characteristic impedance is given by Z0 is equivalent to 1 by Y0 equal to root of Z by Y equal to root of R plus J omega L by G plus J omega C. So this is about the characteristic impedance of the transmission line. We will discuss the next parameters in the subsequent videos. So do like, share and subscribe to the channel for latest updates.